Hello everyone, my name is Adarsh Shukla and I am from Electrical Department second year. Today I am very grateful that I have been given the topic diode operation to do a PPT on. So now moving to the next slide. The next slide is agenda. In this topic we will be discussing about what a diode is, what are diodes made out of, different types of diode circuit models, its applications, types of diodes and their uses. So now moving forward, first we need to know that what is a diode. A diode is a semiconductor device with two terminals allowing the flow of current in one direction only. Here is a circuit symbol shown at the side. Next, we need to know that what diodes are made out of. Diodes are simply made out of silicon, germanium and gallium arsenide. Silicon and germanium has a diamond lattice structure and gallium arsenide has a zinc planar structure. Moving forward, now we will discuss about diamond lattice and zinc planar structure. In both the diamond lattice and zinc lattice, each atom shares its valence electrons with its four closest neighbors. This sharing of electrons is what ultimately allows diodes to be built. When dopants from groups 3 or 5 in most cases are added to silicon, germanium or gallium arsenide, it changes the properties of the material, so we are able to make the P and N type of diodes, P or simply P and N junction. Now moving forward to the next slide. Now we will be discussing about diode circuit models. There are three diode circuit models. The first one is ideal diode model, the second one is the ideal diode with barrier potential, and the third one is the ideal diode with barrier potential and linear forward. So moving to the next slide, we will be now discussing a little bit about ideal diode model. The diode This diode is designed to allow current to flow in only one direction. The perfect diode would be a perfect conductor in one direction, which is also known as forward bias, and a perfect insulator in the other direction, which is also known as reverse bias. In many situations, using the ideal diode of approximation is acceptable. The second one is the ideal diode with barrier potential. The model is more accurate than the simple ideal diode because it includes the approximate barrier potential voltage. Remember, the barrier potential voltage is the voltage at which appreciable current starts to flow. Here is a small symbol showing. So now moving to the next slide. In this, we will be discussing about the ideal diode with barrier potential and linear forward resistance. This type of model is the most accurate of the three. It includes a linear forward resistance that is calculated from the slope of the linear portion of the transconductance curve. However, this is usually not necessary since the RF or forward resistance value is pretty constant for low power germanium and silicon diodes. The forward resistance value is usually in the 2 to 5 ohms range, while higher power diodes have a resistance has a forward resistance value closer to 1 ohm. Now moving to the next slide. In this we will be talking about the applications of diodes in various circuits. Now let's see. reverse voltage protection, rectifying, display, light sensing. These are the applications of diodes in various circuits. Now we will be studying about the types of diodes and their applications. PN junction diodes, which is also known as the basic semiconductor diode. These the basic semiconductor diode is used to allow current to flow in one direction while blocking current flow in the opposite direction. There is a schematic symbol for a PN junction diode and representative structure for a PN junction diode as well. Moving to the next part, the Zener diode. The Zener diode specifically designed to operate under reserve breakdown condition. These diodes have a very accurate and specific reverse breakdown voltage. There is also a schematic symbol for a Zener diode. Moving to the next, the light emitting diodes, which is also known as LEDs. Light emitting diodes are designed with a very large band gap, so movement of carriers across their depletion region emits photons of light energy. Lower bandgap LEDs or light emitting diodes emit infrared radiation, while LEDs with higher bandgap energy emit visible light. There is also a schematic symbol for a light emitting diode. In this symbol, the arrows in the LED or light emitting diodes represents indicate the emitted light from the PN junction or the diode point. So now moving to the next slide, we will be talking about the photodiodes. While LED emit light, photodiodes are sensitive to received light. They are constructed so their PN junction can be exposed to the outside through a clear window or lens, like photoconductive mode or photovoltaic mode. There are two schematic symbols of photodiodes. First is photoconductive mode and the second one is photovoltaic mode. Moving to the next slide, we will be discussing about the types and their applications. Diode as a rectifier, or specifically a half-wave rectifier. The circuit behaves as a half-wave rectifier. It filters out the negative half cycle of the waveform. In the diagram, we can see an ideal diode circuit, and there are two graphs given. The first one is input to half-wave rectifier and the second one is output to half-wave rectifier. Moving to the next slide, diode as a rectifier. In this part, in this diagram particularly, first first D1 is generating the flow of current and then the D2 is conducting the flow of current. So now moving to the next slide. Now the summing up of all about diodes that I have came to know about this topic till now. They are unidirectional device permitting easy flow of current in one direction. Semiconductor diode, basically a PN junction diode. Diode circuit models, ideal diode, two terminal polarity sensitive device, forward bias, zero resistance, reverse bias, infinite resistance. Brief insight of various diodes and their uses, and also the applications of diodes in different circuits and models. thanking you everyone.